530. Engineering System. There are 4 processes, A, B, C and D, involved, and each must produce 1,000 units in a month. The time required to produce 1 unit, the number of machines possessed, and the productive capacity of each of the machines is listed in the table below. You have the process and the time required to produce 1 unit of each, the machines possessed, and productive capacity, where the times are measured in hours and the machines possessed are in units. Process A, it takes 0.4 hours to produce 1 unit, with 3 machines possessed and 150 hours of productive capacity, and so on for each other process. The question is, which of the following processes do not meet the target of producing 1,000 units in a month? Is it A, B, C, or D? In the question, the hint lies in the unit for productive capacity. It is not unit per hour, but rather hour. Hence, one should approach this question by interpreting this as the operation time of one single machine in a month. Let's then take a look at each of the processes one by one. We'll begin with process A. To produce 1 unit of product requires 0.4 hours. In other words, in 1 hour, 2.5 units of product is produced. The operation time for 1 machine per month amounts to 150 hours. Hence, the output of 1 single machine in a given month equals 150 divided by 0.4 equals 375. It's also the same as taking 2.5 units and multiplying it by 150 hours, which is 2.5 multiplied by 150, which also gives us 375. With 3 of these machines, the total units of product that can be produced in a month amounts to 375 times 3, which gives 1,125, which is the total units of products that can be produced in a month for process A. Now let us move on to process B. To produce 1 unit of product requires 0.3 hours. In other words, in 1 hour, 3.3 units of product is produced. The operation time for 1 machine per month amounts to 160 hours. Hence, the output of 1 single machine in a given month equals 160 divided by 0.3, which is roughly 533.3 units of product. With 2 of these machines, the total units of product that can be produced in a month amounts to 533.3 recurring times 2, which is roughly equal to 1,066. Looking now at process C, to produce 1 unit of product requires 0.7 hours. In other words, in 1 hour, 1.43 units of product is produced. The operation time for 1 machine per month amounts to 170 hours. Hence, the output of 1 single machine in a given month equals 170 divided by 0.7, which is roughly equal to 242.9. 242.9 units of product could be made per month in each machine. With 4 of these machines, the total unit of the product that can be produced in a month amounts to 242.9 times 4, which is roughly equal to 971. And finally, for process D, to produce 1 unit of product requires 1.2 hours. In other words, in 1 hour, 0.83 units of product is produced. The operation time for one machine per month amounts to 180 hours. Hence, the output of one single machine in a given month equals 180 divided by 1.2, which equals to 150 units of product can be made for one machine per month. With 7 of these machines, the total units of product that can be produced in a month amounts to 150 times 7, which is equal to 1050. So let's then look at each of the processes. Process A is able to produce 1125. B is able to produce 1066. C is able to produce 971, and D is able to produce 1050. As you can see, the only one that is not able to reach 1000 is C. So process C is the only one that's not going to be able to reach the target of 1000 per month. Therefore, C is the correct answer to this question.